which is, what do you think? What do you think science is? Do you think what we've just done is science? You can answer. Anyone? What do you think? What would you say science is? Is that? Go on. Okay. Yeah, go on then. So that's the names we give it: chemistry, biology, and physics. But there are other sciences as well. Go on.
Things work.
How things work. So that's really interesting because some people think that it's sort of knowing how stuff works, but I don't think it quite is. Any other? Yeah, I'd sort of say it's to do with experiments. What? So it's finding it, yeah. So those two, I think, capture it. It's not knowing the stuff, it's how you find it out. It's asking the right questions and then working out what that tells you about. So you might know lots of stuff if you're a scientist, but there's loads of stuff you don't know. The interesting thing is how you work out stuff. And let me show you something. So hopefully this will work. I don't know if you see, yeah, this should work quite well. I don't know if you've seen this before. So I've got a bottle here of liquid. Yeah. Watch what happens if I do this. So watch really carefully. Okay. That's really cool. That's one of the really coolest demonstrations we do. I could sort of tell you how that works, but that would be a bit boring. It's much better if you can think of the sort of questions you might be able to ask me, simple questions that would allow you to find out what's going on. So anyone want to ask me stuff about this? Yeah, so that's a really good question. Is it just plain water? Here you go. Try some. Go on. Anyone else want to try some? Go on then. It's just cold water. So it's just water. Any other questions?
What temperature is the
That's a really good question. That's a really good question. And here's a thermometer. So I don't know if you can see. Oh, that's
cold.
So that's 0. What temperature is it at?
It's 10. No,
But minus, yeah?
minus 10.
So it's about minus, it's going up a little bit. It's about, it was about -8, -9 degrees in there. What's the freezing point of water?
We've got somebody running around with the mic, so if you want to ask or answer, wait till you get the mic.
You all know the freezing point of water.
0 degrees Celsius.
0. And this is below, that's why all this snow's freezing on the outside. This is below 0, but the water in here, and it's just plain water, hasn't frozen yet. And that's one of the keys to what's going on here. It's called supercooled water. It's below its freezing point. It really wants to freeze. Can I have another volunteer? Yep, go on then. Can you come up? This is really cool. You'll love this. Right, here's another clue as to what's going on. If I put an ice cube in there, you take another one of these bottles. Now what I want you to do is carefully pour this water on top of that ice cube. Okay? Okay, I'll give you a hand. Just really slowly. Look at that. How cool is that? I'll show you how to do this at home later. So it seems like when you put it on top of ice already, it makes more ice. But watch what happens if I pour it on top of something that's not an ice cube. Yeah? It started to go now, but so that gives you maybe a bit of a clue as to what's going on. It needs some ice or something in there already to turn into ice. If you have any questions, ask me. Do you want to sit down and I'll get another volunteer because let me show you something else as well. Right, we'll use the same bottle. Go on then. Do you want to come up? Now, what I want you to do is there's some sand here. Do you want to just take a tiny bit of sand, just put one grain in? There you go. Look at that. It's really cool, isn't it? That's why you can't do this with tap water, because tap water's got little bits of dust in. And those bits of dust act as what's called nucleation sites. They're places where the ice can start forming, because it makes the water line up in just the right way to look like an ice crystal. Go on then, have you got a question? You can do it with salt as well, and I'll show you. Thank you very much. You want to sit down? I'll show you one other thing you can do, and that's explaining to you why it works when you bang it. Do you want to come up? Since you asked the question. Take that bottle and just bang. That's not got really cold water. Just bang it on the table. So what happens when you do that? What happens at the top? It fizzes up, yeah. So it's got bubbles in, okay? And it's thought that it's those bubbles that turn this to ice. And so if I get something like another bottle here, All I want you to do is to tap that bottle on the top with that one. Just gently tap it. A bit more, harder, a bit harder. Ooh, yeah, there you go, look. And the bubble's at the top, that's why it starts at the top. Because the bubble, when you tap it, you're only putting bubbles in top, and then it all turns to ice. What I should do is tell you how to do that at home. The way you can do it at home is all you need to do is to get filtered water. So this is mineral water, it's been filtered, it's straight out of the bottles. You can have, do you want that one? Take it back with you and you can have a nice cold drink later. Thank you. Just need to get the bottles cold enough. And the way I've done that here is to take them down to about -10, but not much below that, is to get a bucket full of ice and put some water in it and then put salt on the ice. If you want to know why that makes the whole thing much colder, you can ask your teachers, because it's a really hard question, so that'll test them out. But it is how they used to make ice cream. Before, I don't know if you ever wondered, how did they make ice cream like in 1700, before they had freezers? What they did was they took snow and ice and they covered it in salt. That made it really cold, and then they put a bowl in the cold stuff, put cream in that and whisked it up, and you make ice cream. So thank you very much for that. That's really good.